Good morning, everyone. I just wanted to post up homework number 51 solutions that are due this morning before class. Basically, I'm trying to make sure that you understand the introduction to circles, which we will get into in this unit, this very short unit this week. So I'm planning on today and tomorrow to be teaching you just a very, very general lesson on section 9.2, which is introducing circles, but mainly talking about degrees and radian measurements, which will be a bit new. And then Wednesday, we will review everything we talk about in section 9.2. And last day, on Thursday, we will have our remaining quiz, the last quiz of the marking period, which is, I believe, it's going to end up being around 50 points, okay? All right, so I'm going to teach you this first lesson. Please just make sure you follow along, all right, and take some good notes. I will post up the filled in notes like I always do after class time today. And then if you have any questions, please just email me, okay? All right, so the first thing I want to talk about in section 9.2 is the standard position of an angle. So we're very much used to seeing all sorts of angles, right? Right angles all over the place. And they have certain degree measurements. Like, for example, we know that this is 90 degrees, correct? And then if we scooch that down and we keep going, then this line here is 180 degrees. And then we talk about, oh, geez, let's keep going. Let's keep going and moving like we would around a clock, right? And as we keep going around, once you do a full rotation, that is 360 degrees, okay? So the main ones that we have are 90 degrees, 180, 270, and 360. So it might be a good idea to copy down this diagram here, okay? And at any point during this lesson, if you need to pause and write a few things down or go back, then you can always do that as well. So the initial side, or where we always start our angle from, is the origin is the kind of like the vertex, right, of this. It's where it's starting from. And the initial side is always going to be the right side of the x-axis, all right? And that's going to always be 0 degrees. So when we start drawing these out, we're always going to start here, all right? And then when we have positive degrees, we work counterclockwise. If you think about a clock, counterclockwise is if we're going backwards, right? We're starting to go left and so forth, okay? Clockwise would be going the way the clock goes, right? Around, which would be going to the right. All right, the terminal side is the ending side. So you have your initial side, and then this terminal side goes around your coordinate plane, okay? But this is what something in standard form will look like. Something really cool that's going to happen that we haven't really thought of is, what if we have an angle that goes around all the way 360 degrees and then it continues to go, okay? Then that degree measurement is going to be something bigger than 360 degrees, all right? Something else new that you're going to see today is there's actually negative degree measures. Negative degree measures are ones where our initial side is here, and instead of going around counterclockwise, if we go clockwise, this terminal side goes this way, it actually, starting at 0, is going to be going in the negative direction. Okay, we'll talk about that. All right, so we're going to draw an angle with the given measure in standard position. Okay, so if I ask you, and I know the first homework questions ask you to draw, okay, an angle, you're going to draw a nice little coordinate plane. Doesn't have to be perfect, all right? You are going to start by drawing your initial side, which is at 0 degrees. And sometimes it might be a good idea to kind of put in the things you know until you get used to doing these. Okay, and if we add another 90 degrees there, that's 270. And then all the way around is 360 degrees. All right, so the way that we're going to do this is, it looks like 240 degrees would be if I started at my initial side and I went, all right, I'm going to 90. going 180, and then maybe I stop around here between 180 and 270. So I stop here. The way that I want you to draw this is I want you to have your initial side, your terminal side here, and I need you to show me an arrow which shows the direction that you went, okay, to get that angle measurement. Okay, so from here to here, that is about 240 degrees. This would be a great little drawing for this, okay, in standard position. So let's try another one, 500 degrees. All right, so I'm just going to draw a quick graph here. We're starting at 0. So I put my initial side here. All right. All right, so let's see how far we're going here. Now, 500 degrees would mean that I'm going past 360, right? So what I'm going to draw here to show that is I'm going all the way around. It's a nice little squiggle here. That's 360 degrees so far, okay? Now, if I take 500 and I subtract 360 from it, all right, I get 140 degrees. All right, so that means I need to go an extra 140 degrees, right? So if I'm going a little extra 140, that means I'm going to go up to 90 again, all right? And I'm not quite at 180, so I'm about here. That's where I'm going to end, all right? And I show that, and I put my terminal side. So this is my angle measurement, all right? There it is. I'm showing that I'm looping around once, all right, and then ending about right here. That would be 500 degrees, all right? Okay, last one on this page. Notice it's negative. So a negative degree measurement, regardless of positive or negative, we always start with our initial side. Okay. Now, negative 50 degrees. When we're talking about negatives, remember, it just means you're starting at 0 and kind of working your way around. So it's kind of backwards then. This would be negative, this would be negative 90. This would be negative 180. Okay. And this would be negative 270. And then you work your way around, okay, back to normal. So negative 50 degrees would be starting at 0 again, but instead of going up and to the left, we're going down. So negative 50 would end around here. We're not quite at negative 90. And that's really kind of a bad line there. So let me start over. All right. So this would be about negative 50 degrees, and this is how I would show it. Okay, I need to see where you're starting from and which way your arrow is going. All right. Okay, so the first part here is drawing these 4 angles. So if you want to pause this and draw them, and then, hit start again so that you can see what they are. Okay, so I'm going to do a quick sketch of each of these. This one starts at 0, 0. I show that. Okay, and it's positive, so I'm going up. Doesn't quite get to 90 degrees. Woo, excuse me. So that would be about 65 degrees, and we can label that if we'd like. Okay, 300 degrees. That means it's going counterclockwise, but it doesn't quite get to 360. So we start at 0, 0. We go all the way around 90, 180, 270. Oh, a little past 270. Okay, and I would draw that in nice and neatly. Hang on, I just wanted to, it's about here, right? All right, and if you want to label that it's 300 degrees around. Okay, all right, next one, negative 120. All right, so we draw in our little coordinate plane. Let me draw this one in while I have this color. All right, negative 120 would mean I'm still starting at 0, 0. Okay, and I'm going backwards here. So this would be negative 90. All right, the next one would be negative 180. So I don't want to get too close there. So it's in between here, okay, until I get to negative 180. So I'm going to draw my line in. I have my arrow of where I started from. I'm showing that I'm going clockwise here. All right, and if you want to label it, negative 120 degrees. Okay. Last one, negative 450 degrees. So that means I'm starting at my standard position here. Okay, and then I have to move my terminal side. Negative means I go this way. So since it's above, well, actually below 360, that means we go negative 360 around, right? And then that means it's an extra 90, right? If you do negative, we're kind of seeing what's the difference between those two numbers, 360 and 450. That's 90. So that means I'm going to go another 90. Okay, and then I'm going to end my terminal side. Okay, and I'm going to say that that's negative 450 degrees. Now, something cool there is if you notice this terminal side, which remember, terminal means where does it end? Okay, it's your initial side. It went around, boop, 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 and then it ended here. There's something called, and I'm going to get to this in the next page, a coterminal angle. A coterminal means that it ends up at the same spot. Okay, so if you notice here, I went around a few times here and I ended up, all right, at this angle measurement, which if you think about it, if it was a positive angle, that would be 270 degrees. Okay, so that's something called coterminal, meaning they land on the same spot. So the first thing we're going to do is we're going to state coterminal angles. And what I'd like you to do is we're not going to draw these out. We're literally just going to use our calculator here. Okay, when things are coterminal, that means we can actually use 360 degrees, all right, to add or subtract from our degree measurement, because 360 degrees is all the way around, all right? So if I add 360 to an angle or I subtract 360 from an angle, I'll get its coterminal angle, which means I'll get another angle that if I were to plot it, it would be at the same spot. Okay, so 360 is the big number here. So the first thing we're asked to do is take negative 45 degrees and state a positive coterminal and a negative coterminal. This is so easy. Ready? Watch. So if I take negative 45 and I add 360 to it, I get a positive number. I get positive 315 degrees. All right. So that means 350 degrees, if I plotted it, would be at the same spot. It's coterminal to negative 45 degrees. Well, I need to give a negative coterminal. So I'm going to take this negative 45 and I'm going to subtract 360. Okay, you're adding and subtracting 360 because that is one full revolution around the coordinate plane. So when I subtract 360, I get negative 405 degrees. Is that the only negative coterminal? No. I could take negative 405 and subtract another 360 and another 360. All of those would be coterminal. So you just need to state one positive and one negative. The second angle measurement that's given is 95 degrees. And they want us to do a positive and a negative coterminal. So I'm going to take 395, and I can do one of two things here. If I subtract 360 from it, then I'll still get a positive, which I can write down. Or I could add 360 and get a positive. So I'm going to take 395 and subtract 360, just because I know that's still going to be positive, and it's 35 degrees. Okay, so how do I find a negative coterminal? Take 35 degrees and subtract 360. It's all relative to 360 degrees. Okay, adding and subtracting it. All right, so if you want to pause this and state one positive and one negative coterminal angle, be my guest. Okay, these are the two samples I have for each one. All right, negative 75 degrees. If I add 360, there I go. All right, if I take negative 75 degrees and subtract 360, there it is. All right, same dealio here with 460 degrees. All right. Determine whether the following angle measurements are coterminal. Okay, so the way that you can determine whether something is coterminal is if I take the degree measure they give me and I subtract 360, subtract 360, subtract 360, and I get to this value, okay, this really negative number, then that means it's coterminal. All right. So for example, if I take negative 34 and I subtract 360, subtract 360, ooh, I got to negative 754. So yes, this is coterminal, meaning if I add or subtract, I get to that value, okay? Negative 34 degrees is positive 1045 degrees coterminal. Well, I don't know. Let's take negative 34 and add 360, add 360, keep going, add 360, and I got to 1046. Those are not coterminal. Okay? Now let's see this. If I take negative 34 degrees and I add 360, do I get to 326? Yes, you do. Okay? And you can do the same thing with this one to determine if these are coterminal. All right? I have one more thing to show you today. Okay, and some of us had talked about this. If you remember when I started teaching chapter 9, I said, please make sure your calculator is in degree mode instead of radian. So here's what I mean by radians, and there's so much I could teach you with this. And if you're going to take pre-calc, you'll learn a lot about radians. But angle measurements can be measured in degrees, which we're used to, or it can be measured in radians, okay? And a radian is the measure of an angle whose coterminal side intercepts an arc at length r, okay? So 1 radian is the measurement of when you have your initial side, okay? And it's the distance, the arc distance, this is an arc piece on the outside here of your circle, from 0, okay, to whatever your radian ending part is, where your radius hits the side of the circle, okay? So the main thing that you should write down here is this, okay? When you have an angle, or when you have a circle, full circle, right? We start at 0 degrees, okay? The measurement of this is 90 degrees, you know that. This is 180. Now we know that this is 270 and this is 360. All the way around, one full revolution is 360 degrees, but it's also 2 pi. You should recognize 2 pi from the circumference formula, 2 pi r. So 360 is equal to 2 pi. So if that's the case, then halfway around the circle, which is 180 degrees, is equal to just 1 pi, right? And this would be half a pi, so pi over 2, all right? And this would be, if we're going from pi to 2 pi, then this would be 3 pi over 2, and there's all sorts of conversions you can do there. But the main conversion that we're going to go with, since it's the easiest, is 180 degrees is equal to pi in terms of radians. Okay, they're different measurements, but they're measuring the same thing. Okay, so here's what you need to remember. It's one little conversion that you do to go from degrees to radians. Okay, and there's one simple conversion to go from radians to degrees. Now, oftentimes, radian measurements have pi in them, all right? So we kind of just keeping pi in there. We don't really do much with it. So in order to go from degree to radians, you multiply your degree by 180, pi over 180, okay? And that will put it in radian modes. If you're going from radian degree measurement to degrees, you multiply it by 180 over pi, okay? So that is kind of your key there. So let's try some. Okay, this is a degree measurement. And remember, when I go from degree to radian, that means I take my degree and I multiply it by pi radians, okay, over my degree measurement of 180 degrees, okay? So what happens there is whatever my degree is will cancel, the degree units there will cancel and I'll be left with radians. So let's try it. 120 degrees, I want to convert that to radians. So I'm going to multiply that by my conversion factor, pi radians over 180 degrees, okay? Degrees cancel, so I'm left with, if I multiply straight across, 120 over 180 pi, you just throw pi in there, and this is in radians. And you can use RAD or rad for short, okay? Now all you have to do is just simplify this fraction as much as you can. No decimals here. 12 over 18 simplifies to 2/3. So 2 pi over 3 radians. So what that means is 120 degrees is equal to 2 pi over 3 radians. Degrees to radians. Now let's go backwards. Radians, how do I know that this is in radians? Well, there's no degree symbol and it has a pi in it. So to go from radians to degrees, you are going to take your radians and you're going to multiply it by 180, okay, over pi radians. What will happen here is your radians will cancel, okay, and oftentimes your pi's will cancel. So let's try one. Negative pi over 12, okay, I'm converting that to degrees. So you are going to multiply this by 180, okay, over pi. Watch what happens. The pi's cancel. You multiply straight across. Negative 180, oh, and this is degrees, over 12. Okay? So I simplify that. 180 divided by 12, which is 15. Is it okay to have negative degree measurements? Yes, we just saw that. Okay? And that's literally what you're doing every time. Okay, so let's try these two, and then I have a few for you to try on your own where you can pause it and then check your answers. Okay? All right, so negative 150 degrees, all you have to remember is the conversion factor. We're putting this into radians, so we're going to be multiplying it by pi radians over 180 degrees. You want the degrees to cancel, one up top and one on the bottom. When you multiply straight across, you get 150 pi radians, okay, over 180. Radians, or RAD, is the unit. So you do need to put that. Now we just need to simplify this fraction. All right, keep the pi in there, and it can either go next to your fraction or up top. Simplify negative 15 over 18. Okay, take a 3 out of the top, 3 out of the bottom, so that's negative 5 over 6, okay, radians. Okay, so these two are equivalent. Okay, last one, 9 pi over 4. We're putting this in degree measurements, so multiply that by 180 degrees over pi. That's your conversion factor. Pi's cancel. Cool. 9 times 180 up top. 9 times 180 is 1620 degrees over 4. Divide by 4. So that means it's 405 degrees. And you just need to put your degree symbol. Okay? All right, so what I'd like you to do is if you want to pause here, you're going to convert each of these degrees to radians and then radians to degrees. So pause here. Okay, and these are all of the 12 solutions to those conversions. Please make sure you practice this and don't just stare at these. Make sure that you're actually, going from degree to radian and going from radian to degree. The only real thing you need to remember is for degree, you're multiplying by pi over 180. Okay? And for radians to degrees, you are multiplying by 180 degrees over pi. Okay? All right. So homework number 52 is going to be based off of the two different sections I just covered, which are the coterminal angles. Some of them have you draw them or state a positive or negative coterminal. So just remember that that means you're adding or subtracting 360. All right, and then the last part is doing some conversions between radians and degrees and radians. Okay, please email me if you have any questions. Today is a sick day for me, so I didn't really need to do a lesson, but I felt bad and wanted to do a lesson for you guys, especially because it's the very end of our semester together. Okay, so please just email me. Tomorrow we will continue in section 9.2 with some circles, not too terrible. And then we'll have review Wednesday, quiz Thursday. All right. If you do have your textbook and you are hybrid, please feel free to bring that in and drop that off on my desk. And we'll go from there. Okay. All right. Have a great day. Bye-bye.